so we know that a 1/4 power is like a 4th root. Our strategy with these root problems is to isolate the radical, which it is on the side by itself, and then get rid of it. So the opposite of a 4th root would be a 4th power. So those cancel. Okay, so then we can set this equal to 0. So if we subtract over the 10x squared, add over the 24. This is like a quadratic, but not quite. We can do the shortcut, so x to the 4th breaks into x squared. Okay, I feel like at least somebody's paper I was looking at, they had this sign backwards. Wrote it down wrong, or didn't change it? Okay. So I need two things that would multiply to a positive 24 and add to a negative 10. Okay, so then we can set each of those equal to 0. X squared equals 6. To get rid of a square, we do a square root, and with that you do, we get x equals plus and minus radical 6. Over here, x squared equals 4. Square root plus and minus would be plus and minus 2. Am I done? No. You need to check these. So if I put in like my 2, 10 times 2 squared minus 24 to the 1/4 power, and that should equal x, which is 2, so that one works. If I want negative 2, do you guys know you can hit second enter and it'll bring up what you just typed in? And then you can go back and change that to a negative 2. So you don't have to retype everything. When I put in negative 2, I also get out positive 2. So does that one work? Does it?
No.
If I put in negative 2, it should equal negative 2. So negative 2 doesn't work. So 2 is good. We need to check the square root of 6. And that's 2.4, and that should equal x. Square root of 6 is 2.4, so the square root of 6 works. If I put in a negative square root of 6, it turns out to be a positive, but it should equal x, so it should equal the negative square root of 6. So the negatives don't work here, only the positives. Is that one okay? I want to do a few more examples today that are just slightly different. So let's say I gave you y to the 2/3 power minus 5y to the 1/3 power plus 6 equals 0. We could write these as radicals. A 2/3, that would be like the cube root squared. A 1/3 is a cube root. But the problem is it's not as easy as the last problem because we have multiple radicals in here. So we wouldn't just be able to cube each side and get rid of everything. Do you notice anything else about this? Look at the 2/3 and 1/3. Yeah, they have the same denominator. In fact, if you have something, we know like a typical quadratic has an x squared, an x, and then just a constant, right? And we've done some that are like a quadratic. If it's x to the 4th, x squared, and a constant. This works anytime, like x is 6, x cubed, and a constant. If you take your middle power, double it, and you get this one, it's like a quadratic. Okay. If I take 1/3 times 2, do I get 2/3? Yes. So this one is like a quadratic. So we could do this with the box method. Okay, 2/3. Why did the 2/3? So when I split that in half, how much would each one get? 1/3. And you notice that's the same as my variable in the middle term, so it works. Then, what multiplies to positive 6 and adds to negative 5? Okay. At this point, we can set each parenthesis equal to 0. Okay, a 1/3 power is like a cube root. Add over your 2. How do you get rid of a cube root? Cube each side. So we get y equals 8. So this one, y to the 1/3, that means the cube root of y equals 3. So if I cube each side, 3 to the 3rd is 20. Are you done? No. Check them. So if I did 8 to the 2/3 minus 5 times 8 to the 1/3 plus 6, it does equal 0. And if I change my 8 to a 27, I see that also equals 0. So both of these do check. Okay, so we can take a lot of these more complicated problems, and if you recognize when they are like a quadratic, it makes it much easier to work with. Let's do say x to the 1/2 plus 2x to the 1/4 minus 3 equals 0. Okay, so what do you notice about this one? Yeah, we can do a box method. You've got your x's in both of these terms, we have a constant. So when I split this up, your exponent is just 1/2 divided by 2, which is 1/4. Okay, multiply to negative 3 and add to positive 2. So if I set those equal to 0, x to the 1/4 minus 1 equals 0, and x to the 1/4 plus 3 equals 0. So if you add over your 1, Keep in mind, a 1/4, you could also rewrite that as a 4th root. So what should you do to each side? So you get x equals 1 to the 4th is 1. Here, x to the 1/4, so the 4th root of x equals -3. And that would be a 81. Okay. Then, am I done? Check. So 1 to the 1/2 plus 2 times 1 to the 1/4 minus 3, that equals 0, so that one worked. If I put in the 81, I get 12, so did that one work? No, so this time only one answer worked. Okay, one more of these. If I said 15x to the -2 plus 19x to the -1 plus 6 equals 0. Alright, what do I do? Okay, can I do the shortcut this time? No. Okay, 15 times 6, so we have to multiply to 90 and add to 19. Yep, so 10 and 9. Each of those we get an x to the -1. So when I factor, this would be 5x to the -1 and 3, 3x to the -1 and 2. Okay, so if I set these equal to 0, what does an x to the -1 do? What does that negative do? Right, this 5x to the -1 is the same thing as 5 over x. Subtract over your 3. So then if we multiply by x on each side, divide by -3, we get a -3/5. So 3x to the -1 is 3 over x equals -2. Multiply our x, divide by -2, and that's a -3/2. And then of course, what should you do? Check them. Both of these are going to end up working. For the sake of time, I'm not going to plug them in.
Why on the -3?
Yeah, that should be a -5 over 3, shouldn't it?
Yeah.
Thank you. Because I divided my 3. Alright. Any questions for me? So yesterday I posted the Math Excel assignment. Now you've got quite a bit of time to work on that, and any questions that you have, please ask me. The whole thing is due tomorrow.